Okay, all right. Good afternoon, everyone. Thanks so much for coming to the presentation. I'd like to thank organizers for this great conference. I'm enjoying a lot so far. In my talk, I'd like to talk about our recent results on effect of deception in social network. So, unfortunately, people lie, and especially in social network, they lie more than regular time. So we just analyzed effect of lying, effect of deception in two different social network problem. The first one is influence maximization, which is just which users will be more influential than others. And the second one is polarization, another issue in social network. So we are going to see effect of deception in these two problems. This is my rough outline. So as I said, deception appears to be surprisingly common among humans within social networks. And as I said again, this is more common in online than face-to-face interactions. When I see statistics, it was actually amazing. So on average, I think people have 8 lies on average, but when it comes to a day actually, and then when it comes to online social networks, it becomes more than that. So what did we do in our research project? We asked these two questions. How does deception affect influence maximization in social networks? In other words, if people lie in social network, are they becoming more influential? Are they, and when I say influential, I mean whenever they make a post, their post is reaching too many people in a short amount of time. And the second research question we asked is, how about polarization? How does deception affect polarization? So if people lie in social network, is the social network becoming more polarized or not? To answer this question, we first use a special data structure. It is called sheaf data structure. And in this, actually, before this information diffusion model in social network, the classical information diffusion model assumes everyone is honest. So, and when I say honest, I mean their private opinion and their public disclosure are the same. But of course, this is a very rough assumption, and this is very limited because people privately think and publicly disclosure, actually, they are different. They could be different, I should say. And there is a very new diffusion model, which is built maybe just 2 years ago. It's called in sheaf data structure. So what is that data structure allowing is, it is allowing to have private opinion and public disclosure be different. So if someone can support a political party, but they can disclose their idea in their social network, totally the opposite. And another thing that this information diffusion model is giving us is we can express their opinion basis. So, for example, if I like to decide on vaccination, I may use religion and politics as my opinion basis, but some other people could use risk-taking and health as their opinion basis. So when I say opinion basis, I mean they just consider those two dimensions while deciding to have vaccine. And this model is allowing to selectively lie their neighbors, because as I said, private opinion and public disclosure are different. That's why people can easily selectively, by the way. So I can lie one of my follower in social network, but I can be honest to other one. So this is actually an example over here. So that V1 and V2 are two users, and they have connection E. We call it edges. So they just discuss religion and politics. Sorry, they just discuss vaccination, and then the first user's opinion basis is religion and politics. The other one is risk taking and health, and then they just publicly disclose their, for example, the one on the right is supporting vaccine, but the one on the left is opposing vaccine. So this is how they actually disclose their private opinion. And then when it comes to lying, actually, we also realize that there are different lies. For example, there are pro-social lies. The purpose of pro-social lie is just try to protect someone or benefit someone. For example, if my son is learning how to play piano, if he's not playing well, if I say, oh, you are playing really well, go ahead. This is actually a pro-social lie. I lie him to make him actually better. But there is also antisocial liar. So these are totally intended to hurt someone. So just in that hurt can be in many ways, but our goal, the goal in this lie is just negative, hurting someone. So what we do in our model, we just assume that everyone has an opinion between -1 and 1 in our social network. And -1 is meaning totally opposing an idea. 1 is meaning totally supporting the idea. And this is our diffusion model. As you see here, if a user is honest, whatever he thinks, he just says. So his private opinion is Xi, and his public opinion is also Xi. But if someone is a pro-social liar, it also, that user also decide his public disclosure based on what others think. This XJ is the opinion of his neighbor, his follower, or his friend in social network. So he's just mixing his ideas and mixing his friend's opinion. And there is actually a parameter tau here. It is just measuring how to mix all those two opinions. And antisocial liar is also doing that. But as you see here, there is negative in between. That means that, so whatever his friend is thinking about at some topic, he is just disclosing opposite as his opinion. But this is our opinion. This is our actual deception model. And as I said, we worked on two different problems: influence maximization and polarization. And in the influence maximization, our goal is to find who are the most influential users in the social network. What we did actually, we just use our information diffusion model and define a new technique called Laplacian centrality to understand who are most influential if someone is lying in social network. And for the polarization problem, we did a similar approach. What we did is actually, we again selected the most influential user based on this on the previous measures, Laplacian centrality, and we set his opinion to 1 and the rest of the user's opinion to 0. And then we just, in our model, we just kept this influencer's opinion at 1 and let others' opinion change. And then we just look at how those opinions are accumulating. Are they actually polarizing in the social network throughout the time, or are they hand to hand actually throughout the time? All right, let's talk about our experiments. First of all, we worked on 4 different social networks. This Oz network is just a high school friendship network. Congress is where there may be analyzed actually. This is the network of the US Congress. And Instagram and Facebook are, of course, online social networks. And okay, these are the results. So x-axis is throughout the, as I said, we have a honesty parameter tau. Whenever tau is equal to 0, everyone is totally dishonest. And whenever it's equal to 1, everyone is honest. So x-axis is that honesty parameter. And y-axis is the influential score. Having a bigger score means being more influential. And if you look at the colors, there is blue color is honest users, red is pro-social liar, and yellow is anti-social liar. As we see in actually all 4 data sets, liars are more influential. Their influential score is always greater than honest users. And of course, when honesty parameter is equal to 1, they all become honest. That's why their influential score are becoming the same. So regardless of the whole data set, so liars are more influential. But which type of lie is more influential than the other? Remember, we had pro-social and anti-social liars. We also look at, area of these curves, these influential score curves. We just realized that anti-social liars are slightly more influential than pro-social liars. And of course, those 2 liars are more influential than honest people. And the second set of results is again about polarization. Remember what we did? We just set the seed node's opinion at 1, and all remaining is actually 0. And then we just run our simulation. and you see time values at the very bottom. So as you see here, okay, the first row is for honest user. So the first row, this seed note is honest. And as you see here, if you look at opinion change throughout the time, everyone is becoming actually a consensus at the end of the time. So there is no polarization if someone is honest. But if you look at the second row is pro-social liar and the third row is anti-social liar. If you look at these, for example, pro-social liar, at the very beginning of the information diffusion model, everyone is starting to think differently. And then as time goes, there are some groups of people. For example, if you look at the rightmost picture, there are two clusters who are totally opposing the idea. There is one cluster who are supporting the idea. And in this big cluster, okay, 2 minutes, I'm almost done. In this big cluster, there are again polarization going on. So we see similar observation also for anti-social liar. So as you see here, when people lie, they result a deeper polarization in social network. We did the same example, same actually model for our data sets. Remember, we had 4 different data sets. We used actually 2 different polarization metrics. The first one is standard deviation, and the second one is polarization index. As you see results, again, liars are causing more polarization than honest users. And between 2 types of liars, anti-social liar are actually causing more polarization. All right, as the conclusion, as I said at the very beginning, we are investigating the effect of deception on 2 important problems in social network: influence maximization and polarization. We use a specific model for deception and also opinion dynamics. We define a new metric, which is called Laplacian centrality, which is able to identify influential users when there are liars in the social network. We also came up with a model for polarization. And then our results clearly shows that when users engage in deception, so when they lie, they become more influential in social networks than honest users. And then when then there is also a lie in social network that is increasing polarization among all the network members. And this is the paper that we use our polarization information diffusion model. That's all from me. Thanks so much for your attention.
Any comments or questions about the presentation? Go ahead. I'll just repeat your question.
Thanks.
Go ahead.
I just want to know if he has tried any models with additional variables in it, because you had 2 main, which were anti-social and pro-social.
Did you hear it? Did you? The question is, did you have additional variables in the model?
No, we just took our graph data structure, social networks, and then we just randomly actually divide all the users into 3 classes. So the first one is honest, the second one is pro-social liar, and the third one is anti-social liar. So we actually didn't use real, real social network where we know who are lying in the social network. We just randomly selected. That's why we didn't take any assumptions at the very beginning.
Did you have any specific variable that you feel like may be influential?
One of the variables that seemed to be missing, so the anti-social was about lying to hurt somebody else. The pro-social was about lying to benefit somebody else. But I think there's a large subset of users that lie to benefit themselves, which might be a valuable variable.
Did you hear it?
Yeah. Actually, there are in lying literature, there are 4 different lies. There are actually 2 others I skipped because it was difficult to model those type of lies, and I don't even remember what they were. I think maybe one of them could be what you said, but we just went with this anti-social and pro-social liar. But benefiting themselves could be also a part of maybe anti-social liar. I'm not sure actually, because if you benefit yourself, maybe you hurt some other people, but that's not of course for sure, right? Yeah, we only consider these two cases, but there may be other cases as well. Yeah, you are right.
Thank you.
Mhm.
All right, so we are out of time. Thank you so much for the presentation. So we'll move on to
Thanks so much.